Today we are talking about isosceles triangles and the theorems that go along with them. An isosceles triangle is a triangle with at least two congruent sides. So that means two of its sides are congruent, that they have the same measures. Our first theorem is the isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in my picture, if I have AC is congruent to BC, then the angles opposite AC and BC are congruent. So that's angle A and angle B. Okay. With our isosceles triangles, angle C is the vertex angle, and angle A and angle B are base angles. Okay, so we're going to refer to these angles later on. Theorem 19 is a converse. This is where we go through and we flip the statements. So it says, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if angle A and angle B are congruent, then the sides opposite those angles are also congruent. So AC is congruent to BC. So the first theorem, we go from sides congruent to angles congruent. The second theorem, we go from angles congruent to sides congruent. We're going to use those theorems to go through and explain why certain parts of triangles are congruent. So the first one is AB congruent to CB. That is these long sides right here. So I want to know, are the purple sides congruent? So thinking about those two theorems, the first one said if I had sides congruent, then my angles were congruent. But I don't know if AB and BC are congruent, so I can't use the first theorem. The second theorem said that if I have angles that are congruent, their opposite sides are congruent. I have angle A and angle C, right? And those little marks in the corners mean that they're congruent. So I can use theorem 19, or the converse of the isosceles triangle theorem. So is AB congruent to CB? Yes. We know that angle A is congruent to angle C. So AB is congruent to BC or CB. By the converse, isosceles triangle theorem. It says if I have two angles that are congruent, their opposite sides are congruent. Okay, let's look at B. It asks, is angle A congruent to angle DEA? So let's go through and look at it a little closer. So I want to know, is this angle congruent to that angle? So looking at this triangle, I notice that I have two sides that are marked congruent. And by theorem 18, or the isosceles triangle theorem, if I have two sides that are congruent, then the angles opposite those sides are also congruent. So we can say that yes, angle A is congruent to angle DEA. And we know that because AD is congruent to DE. So that means angle A is congruent to angle DEA by the isosceles triangle theorem. So all we're doing is we're looking for sides that are congruent or angles that are congruent. Next, is angle WVS congruent to angle S? We'll label this one 1, and the second one is TR congruent to TS. So we're going to look at the first one. So we're only looking at this little triangle. I want to know, is this angle right here congruent to this angle right there? Looking at my little triangle, WVS, I notice that VW and SW are congruent. So by the isosceles triangle theorem, if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So, is angle WVS congruent to angle S? Yes. Okay. VW is congruent to WS. So then we know that angle WVS is congruent to angle S by isosceles triangle theorem. Okay, number 2, is TR congruent to TS? So we are looking at these sides of the large triangle. Okay. Ultimately, I want to know, is this whole side congruent to this whole side? We know that from 1 that all 3 of those angles are congruent. Since angle R is congruent to angle S, then we know by the converse that if 2 angles are congruent, then the sides opposite those angles are congruent. So 2 is yes. We know that angle R is congruent to angle S. So that means TR is congruent to TS by the converse isosceles triangle theorem. Now it is your turn. Pause the video, work through these 4 problems, and then check your answers. Okay. 1, VT, this is big long side, is congruent to VX. UT is congruent, it says, to YX. We match up sides, that also means UV. VU is congruent to VY. Okay. And last, angle VYU, so this angle right here, is congruent. I picked VUY, so this angle right here. You could also have picked any of these other angles that are marked. They are all congruent. Okay, another theorem. This is labeled theorem 20. And it says, if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So we need a little bit of vocab here. A bisector is the line that divides something, in this case our angles and our sides of a triangle, into two equal parts. Okay. So a bisector is the line that divides something into two equal parts. A perpendicular perpendicular bisector is a line that divides something into two equal parts at 90 degrees. Okay, so if I have a picture and I have a line that bisects, okay, it's a perpendicular bisector if it creates 90 degrees or right angles. So back to our theorem, if I have a bisector for the vertex angle, then, so we get two equal angles or two congruent angles. If that's true, then on my base, so AB in this case, AD is congruent to DB, and angle CDA and CDB are right angles. So we get two right triangles. So to use that theorem, we want to know what is the value of x. And x is for that angle, and this 54 is for angle A. So by looking at this triangle, looking at the big one, so ABC, I notice that AB is congruent to BC. I also notice that BD is a bisector, so that means that these two angles right here are congruent. And by that theorem 20, because these two angles are congruent, that means AD and DC are congruent, and the angle ADB and angle CDB are right angles. Now that I have this triangle, I'm still missing a side, but because we have isosceles, a big isosceles triangle, and angle A is 54, and angle C is also another base angle, it is also 54 degrees. Now that I have a triangle filled in with all my angles, I can solve for x. So I'm going to draw a triangle out so I can just look at one of them. So I have my triangle. Angle D is my right angle, B is my x, and C is my 54. With triangles, we know that all triangle angles add to 180 degrees. So that means that if I do 54 plus 90 plus x, that equals 180 degrees. Okay. Now I need to solve for x. So I'm going to combine like terms and add my numbers together. So 54 plus 90 is going to give me 144 plus x is equal to 180 degrees. I want x all by itself, so I'm going to subtract 144 from both sides. 144 minus 144 cancels out and gives me 0, so I'm left with x. On the right side, I have 180 minus 144. Okay. And I get 36. So x is equal to 36 degrees. Okay, so using theorem 18 and theorem 20, and then knowing that triangles add up to 180 degrees, I can solve for x. Okay, here is another example. Suppose the measure of angle A equals 27 degrees. What is the value of x? So I know that A is 27 degrees. I also know, by looking at my diagram, that AB and BC are congruent. So that means I have an isosceles triangle. Because the sides are congruent, my angles are also congruent. So A and C are congruent. So angle C is 27 degrees. Also, by looking at the diagram, DB is a bisector of angle B. So that also means that DB is a perpendicular bisector of AC. So AD and DC are congruent. And I have right angles. Now that I have a triangle all set up and I have my 3 angles, I can go through and solve for x. So angle D is 90, B is x, C is 27. As previous, all triangle angles add up to 180 degrees. So we have 90 plus 27 plus x equals 180 degrees. So combine like terms, 90 plus 27 is 117 plus x equals 180. I'm going to subtract 117 from both sides. 117 minus 117 gives me 0, so I'm left with just x equals 180 minus 117. So x equals 63. So x equals 63 degrees. Okay. Now it's your turn to solve 5 and 6. Pause the video, go through, solve, and then check your answers. Okay, here are the answers for 5 and 6. On 5, x is equal to 80, y is equal to 40, because those two angles are both 50, so I add them together, and I get 100, so x plus 100 equals 180, minus 100 from both sides, x equals 80. For y, these two angles are both y, so I get y plus 100 equals 180. 2y plus 100 equals 180, minus 100, 2y equals 80, divide by 2, y equals 40. On 6, we need to use the idea that we know about straight lines and angles. If I have two angles that make a straight line, they add up to 180 degrees. So 110 plus my mysterious angle is equal to 180. Subtract 180 from both sides, so that angle equals 70. Because this is an isosceles triangle, these two bottom angles are congruent. So that means if one is 70, the other is 70, so y equals 70. To find x, I need to go through and add up all my angles. So x plus 70 is equal to 180 degrees. 70 plus 70 equals 140, so I subtract 140 from both sides and I get x is equal to 40. Okay, next, equilateral triangles. This is a triangle whose sides are all congruent. Okay, so a triangle whose sides are all congruent. So we've talked about isosceles triangles where at least two sides are congruent. So an equilateral triangle is a triangle whose sides are all congruent. Since triangles have three sides, that means an equilateral triangle is a triangle with 3 sides that are congruent. This means the equilateral triangles are a subset, kind of a part of isosceles triangles, because isosceles triangles only require that we have 2 sides or more. My equilateral triangle has all three. So we can use that idea of isosceles triangles and equilateral triangles being isosceles triangles and use basically the same ideas and theorems. So if a triangle is equilateral, then the triangle is equal angular. Okay. Equal angular, equal angles. So it just means all their angles are the same. So in my triangle, if xy is congruent to yz, and that's all congruent to zx, then angle x is congruent to angle y, which is congruent to angle z. Basically, you treat it as an isosceles triangle, so these two are congruent. You rotate, you look at these two, those two are congruent. So it just kind of rotates the triangle and you get all the angles are congruent. Theorem 19 being applied to our equilateral triangle is if a triangle is equal angular, then the triangle is equilateral. If all three angles are the same, then all three sides are the same. Okay. We need to look at equilateral triangles just a little bit more. So I have my equilateral triangle, so each side is equal or congruent. And then we also know that all my angles are congruent. I want to know what is x. Okay. Since all three of these angles are the same, that means all three are x. So we know that all triangles angles add up to 180 degrees. So I'm going to have 180 is equal to x plus x plus x. So a 180 equals x plus x plus x. I have 3 x's, so 180 equals 3x. I want x by itself, divide by 3, divide by 3. So 60 equals x. So this is 60, that is 60, and that is 60. Okay. So all angles in an equilateral triangle are 60 degrees. Okay, we just figured that out. So we're going to keep using that idea. When we see an equilateral triangle, we know they add that each of those angles is 60 degrees. Okay, we are going to skip this problem and go to this one. Okay, so the equilateral triangle and the isosceles triangle shown here share a common side, and they share BD. I want to know what the measure of angle ABC is. So I want to know this angle right here. Okay. To find that out, I need to find out the pieces of B. So let's look at triangle ABD. So A, B, D. I know that those two sides are congruent and that this side is 66. Since those two sides are congruent, that means my angles opposite are congruent, so 66 is also there. Alright, and this is what I want, is that angle B. So I know all three angles have to add up to 180 degrees. So 66 plus 66 plus x equals 180 degrees. 66 plus 66 is 132 plus x equals 180. Subtract 132, subtract 132. So x is equal to 48. Okay, that's my first piece. Right, that's my x right here. I now need to know what y is. So we're looking at triangle BCD. And I know that all three of those sides are congruent. So that's an equilateral triangle. It told me I had that. And we know from what we just did on the previous slide that all three of these angles are congruent and they all equal 60. So y is equal to 60. Okay, but I don't want just x and I don't want just y. I want x plus y. So x plus y is equal to 48 plus 60, which is equal to 108. So angle ABC is equal to 108 degrees. Okay, so using my knowledge of isosceles triangles and equilateral triangles, I was able to find the measure of ABC. Okay, do you know how? These are the 5 questions that are the lesson check for today's lesson. You can go through and complete these on Canvas to get points, or you can bring them in to me and show me your answers and get credit.